With the case of a drone, you don't know what is the signal strength from the controller to the drone. J over S may not be the best technique. Maybe J over N, it could be a good window. The reason I'm saying that is because I'm going to justify for myself analyzing jammer from a coverage perspective. So you can predict the coverage of the jammer. And let's say next 70 dBm is a strong signal. That's what you, for example, you expect as a wanted. Let's call it a wanted. If say J over S, you need to be equal to 20 dB. So the jamming signal must be 20 dB greater than the signal. Another way to look at this is to say J is equal to neg 50. All right, that's a simplified way. If you, I can build a scenario where you know where the wanted signal is variable based on your knowledge of the controller. But if you don't know where the controller is, then you can't really use J over S prediction directly. But you could use the value you know for the equipment to derive the minimum RSSI from delivered by the jammer to jam the drone. So that's what I'm going to use in the example here. This is my jammer here. So this jammer configuration. So I'm using a simple way to model the jammer. We have a jammer model. I can go and add station here. I can add a jammer. So you can put the jamming power. So in that case, it's 500 watts. So you can use something less. You could use something like 40 watt or 50 watt. We're looking at 63 then. And this is the frequency. That's the model. Okay. Here is your antenna. You can put the actual antenna pattern. You can import the antenna pattern from your vendor. So usually when your vendor should supply you with the antenna radiation pattern. If it doesn't, they just give you a data sheet. It's fine. We can still survive with the PDF. Okay. I can go delete all, and I can start adding. So at 0 degree, we've got 0 degree attenuation. At 5 degrees, I've got 1.5 degree attenuation, and then you can make symmetry if you want. Okay, something like this. So usually we import the entire pattern from 360 degrees. Okay. And you can see here we can import from Planet format, from FCC format, ADF format, MSI format. You can go and import, for example, something from our database or from the vendor. Okay, so I'm going to quickly import something from our software. You see here I've got some antenna patterns. I'm going to use something like Yagi. So it will look something like this. And then you've got the polarization. You've got vertical, horizontal, circular, and then mix. Okay. Now continue with this. You've got here the advanced. So this is your coverage threshold. So here you can put your neg 50 dBm or whatever is the value we are using. Okay, so this is my jammer. Okay, so the jammer I modify is this one, right? So isolate it. I just to clean up the screen a bit, and I deactivated everyone else. Yeah, this is my guy. Yeah. Now let's get the coverage. So we can get the jamming at multiple elevation if you want. Or you can do it just at one-on-one elevation. You can find the minimum jamming height. In fact, the minimum jamming height. The higher the UAV, the more clear. The more clearance you have. Obviously, to a certain level, if you're flying too high, it's another problem. So let me show you what we have as functionality. We have variable height, so you can find the minimum elevation, or the max field strength, the strongest signal. In the range of height, it can show you the strongest signal, or it can give you the signal at the minimum elevation that signal exceeding neg 50 dBm. That's the fixed elevation first. This is the what is the drone height? Say 50 meters up to say 5 kilometers from the jammer. Yeah, that's it. Let's run it. So now we're predicting the J, and then we check the value if it is exceeding the requirement. Say it's 50 dBm. And what I usually do as well after that, I usually add confidence. So confidence, say neg 50 dBm, say 50% confidence. And then I say, for example, neg 41 dBm, okay, dBm with a confidence of 95%. So we use normal distribution to establish more confidence. So this is a fixed orientation jammer. I could also rotate it if you want. If it is rotatable, if it's steerable, I can also do the same with the range of values. Okay, let's first examine this one to understand. This is one layer. Okay, so there's a 50-meter height. So it show you where are the locations you cannot jam. So this one's here. Okay, you cannot jam the area here. Why we can't jump the area? Let's establish why. Let's have a look. Yes, you see it? Let's put the 50-meter height here. That's the guy. You see how the signal dropped? This is indoor. This is outdoor.
Yeah.
Outdoor is recovering, that's for sure, but it's not reaching to the line of sight anymore. So you can predict the signal. If there is a building height above 100 meter, exceeding 100 meter, then yes, it would show you what the signal level is. Okay, and then after that, if you want to use the idea of neg 50 dBm is 50% chance, assuming 20 dB, this is 20 dB, signal jamming to signal. So you can say here neg 40, for example, and you say this is 95%, 30 dB now. I don't know the 20 dB if it's 50% or higher, so it depends on how they was derived. And then say this is brown. All right, this is the red area. This is the brown area here. I should also show you the other functions. So here, coverage, network planning, network calculations. So variable height, field strength, variable height coverage. So this is a batch process. It will dump the coverage into a repository. Okay, it will just dump the coverage into repository somewhere on the computer. The idea is to automate the coverage predictions of different elevations. This is the minimum elevation. So the lowest height where the signal is still able to jam as RX. Let's have a look at it as RX. So let's say I'm going to start with 50 meters height up to 100 meter height with a step of a 10 meter. So this is going to run multiple coverage predictions, multiple layers. 50, 70, 90, 100, okay? And then out of these different heights, it will tell you what is the minimum height, with the signal exceeding neg 50 dBm. So in fact, it's the lowest possible jamming height. So if the drone fly higher, you have more chance that you're going to jam it. I mean, this tool has so many features. You know, have measurements, components, DF, radar, satellites, onto multiple microwave coverage analysis, interference analysis. Right away, here we go. So what you're looking now at is I see here that the legend is in meters, default coloring. So you see that legend is in meters. 30 meter is the minimum, and 90 meter is the maximum. What does the blue area mean? Obviously, this is a network of jammers, not just one jammer. The blue means a target in the blue area. You can jam it as soon as he's flying 30 meter height or higher. But this urban here, in the city, it's more challenging. So in the city, you can see the red area, for example. You can only jam it if you're flying 78 meters or higher. The yellow is 69 meter or higher. The green is 57 and so on. So some areas you cannot jam it. You cannot jam it in this area here. There's no coverage. So that's what the heat map represents. That's the idea of minimum jamming height.